What if time isn't as simple as we think? What if it doesn't move the same way everywhere or for everyone? What if out there in space, time itself can slow down, speed up, or even bend? Time feels constant, reliable, a steady ticking clock that never changes. But in the universe, time is far more flexible and far more mysterious.
Before we dive in, if you want to explore more incredible truths about space and the universe, make sure to subscribe, like, and stay with us, because the deeper we go, the more reality begins to shift.
Now, let's talk about time. On Earth, time feels normal. Seconds pass. Minutes move forward. Days turn into nights. Everything seems predictable. But that's only because of where we are. Because time is not universal. In space, time behaves differently depending on two key things: speed and gravity. Let's start with speed. The faster you move, the slower time passes for you. This is called time dilation. It comes from Einstein's theory of relativity. And it's not just an idea. It's real. It's been tested, proven, even experienced.
For example, astronauts on the International Space Station experience time slightly slower than people on Earth. The difference is tiny, but measurable. Now imagine going much faster, close to the speed of light. Time wouldn't just slow down a little. It would slow dramatically. Minutes for you could be hours, days, or even years for someone else.
Now let's look at gravity. Gravity doesn't just pull objects together. It bends time. The stronger the gravity, the slower time moves. Near massive objects like planets, stars, or black holes, time slows down.
Near a black hole, this effect becomes extreme. If you were close to a black hole, time for you might pass incredibly slowly, while far away, the universe continues as normal. This means two people in different parts of space could experience completely different amounts of time. One could age years, while the other ages only days. Time is no longer fixed. It becomes personal, relative.
Now think about this. Every time you look into space, you are looking into the past. Light takes time to travel. So when you see the moon, you're seeing it as it was about 1 second ago. The sun, about 8 minutes ago.
Distant stars, years ago. And galaxies,
millions or even billions of years in the past. The deeper you look, the further back in time you go. In a way, telescopes are time machines. They don't just show us space, they show us history.
Now here's where it gets even stranger. What is time, really? Is it something that flows, or something we experience? In physics, time is treated as a dimension, just like space. Together, they form something called space-time, a fabric that makes up the universe. And just like space can bend, so can time. Mass bends space-time. Speed stretches it. And everything that exists moves through it. Right now, you are moving through time at a constant rate. But change your speed or your environment, and that rate changes too. This leads to an incredible possibility. If time can slow down, can it stop? For light itself, the answer is yes. At the speed of light, time does not pass. From the perspective of a photon, the moment it is created and the moment it is absorbed are the same instant, no time in between, which means light does not experience time, and that challenges how we think about reality. Because time is not something that happens everywhere the same way. It depends on where you are, how fast you're moving, and how strong gravity is around you. Now, let's imagine something. You travel on a spacecraft at near light speed. You journey across space for what feels like a few years. But when you return to Earth, decades have passed. Everyone you knew has aged far more than you. This isn't science fiction. It's a real prediction of physics, and it has been tested with precise clocks. Time can stretch, and that leads to one of the biggest questions of all. Can we travel through time? Forward in time is already possible. In fact, you're doing it right now. But traveling into the future faster than others, that's achievable through speed and gravity. But going backward in time, that's where things become uncertain. It may not be possible, or it may require physics we don't yet understand. Because going backward creates paradoxes, contradictions, events that cannot logically exist, and the universe may not allow that. So where does that leave us? Time is not just a ticking clock. It's a part of the universe itself. flexible, stretchable, affected by motion and gravity, and still not fully understood.
So the next time you look up at the stars, remember this. You're not just looking into space. You're looking into time, into moments that happened long ago. Light carrying history across the universe, just to reach you. If you've made it this far, take a moment to like the video. It really helps more people discover the wonders of space. And if you want to continue exploring the universe and its deepest mysteries, make sure to subscribe. Because in the next video, we're going to answer a fundamental question. What is energy in the universe? What powers everything, from stars to galaxies, and even you? Until then, keep looking up, because time isn't just passing. It's part of something far greater.